Hey guys, I am going to be going over the review that Mr. Hawkins put together for us. Just a reminder, this is a review of transformations, our rotations, reflections, and translations. The last four lessons that we have looked at, we've talked about rigid transformations, and just a reminder, a rigid transformation is one that does not change size nor shape. In other words, the new shape that is created, the image, is a congruent shape. And again, those transformations that we're looking at are rotations, reflections, and translations. We're going to be going through the steps that you've learned. What I'm doing today is just giving you an giving you the answers, what they should look like when you've finished doing the expected transformation. So slide one is a reflection, and a reflection takes points from one side of a line to the other. We call that the reflection line or the line of reflection. And those points should be perpendicular. They're on a perpendicular line to the reflection, the point of the line of reflection. So the tools that we're allowed to use here are the perpendicular line and the circle tools. So in order to do that, we start first of all by making those perpendiculars and then using the circle tool, and you can connect your circle to one point because every point on that perpendicular bisector is going to be equidistant to both the original points G, E, or M, and the image points G prime, E prime, M prime, and then reflect that over the line. The next slide is translation, and a translation is going to take points to other points in a specific direction and a given distance, and we call that our vector, or it's called a directed line segment. So those are the two terms that will be used, either vector or directed line segment. And here we start using parallel lines, and our lines have to be parallel to that vector or to the directed line segment. And then the compass we're going to use to make sure that our points are the same distance as t, or as our vector is long from the original point. So we use that to set the radius of our circle and then set the center of the circle at the original points P, O, or G. Our next slide is a rotation. And this is the first transformation that we actually get to use those transformation tools. So before this, you should be using tools just from the construct. This construct here, this is the first one that we get to use transforming tools. So the transformation we're using is a rotation, and just a reminder, if you are doing a rotation, it will always go in a counterclockwise direction unless you put the negative in front of it. Then it'll go in the clockwise direction. So for this one, we're going to do counterclockwise, so we don't need any negatives, and we select the entire figure. It should rotate 110 degrees. Now this one is saying do a reflection and a translation, and I've made these in different colors for us so that we can talk about that. So the first thing we're going to do is reflect, and when we reflect, see that perpendicular line that I made that goes through A and A prime, and then there was a circle used to connect that over as well to make sure that A prime was at the correct location, the same distance from that intersection as A is. Then did that with A, B, and C to get A prime, B prime, C prime. Then to get A double prime, B double prime, and C double prime, we used the vector S and made parallel lines. That's the line, I kept the line B prime, B double prime there for you to see that that is the line that was used to do the translation. And then the length of that translation, the distance from B prime to B double prime, is the length of the vector S. And to do that, we use the compass tool, making our radius the length of the vector S. And you do that again for all 3 points in the green figure to get the red figure. Then translation and rotation. Here we are doing the translation along vector G first. And so in this case, again, we're going to have lines that are parallel, but this one's just asking us, what is this? What's happening here, the transformations? This one was actually first a translation, and the way you would write that properly would be to say this is a translation of triangle ABC along the directed line segment or vector G, and that goes to image A prime, B prime, C prime. Then the triangle A prime, B prime, C prime is rotated 140 degrees clockwise around point C prime to make the image A double prime, B double prime, C double prime. Now, in order to do this, you do have to use your construction tool and figure out what that angle is. And that is done by using the angle tool and then going from A prime to C prime and then out to A double prime. So you do have to double check that, and that was a 140-degree angle. And since I'm rotating it this way, that would be, I'm going from in this direction, that's clockwise, so I have to use a negative 140 to get it there. You might even add that to your description. Okay, this one was saying use rotations and reflections to move ABC onto DBE. And I did this and just left the final pictures there for you so you could see the little triangles. So first, reflect triangle ABC over line BC. And just a reminder, when we talk about lines or line segments, and we're using points, we have to use 2 points. It's not line B, it's not line C, it is the line that's connecting B and C. So we call it line BC or line segment BC. And so we're going to rotate it there first, and that gives us this orange image. And then we rotate it 135 degrees counterclockwise. Again, I had to measure from D through B down to this point that is the corresponding point for D. And so that is 135 degrees, and we're going in the counterclockwise direction. So I need to say what direction I'm going in. And then the final location is going to be triangle DBE. Now all three. It's saying rotate ABC 60 degrees clockwise around point C. I'm not going to do the explanation on this one. I think you guys by this time should understand. We're going from the blue figure to the orange one, and then we go from the orange figure reflecting over to the green one, and then with the green one taking our directed line segment W takes us down to A triple prime, B triple prime, C triple prime. And then are these congruent? Now, one thing we can do is say, okay, I'm assuming here that A corresponds to D, C is to correspond to E, and B is to correspond to F. So we try connecting those lines that are supposed to be corresponding to one another, and we notice right away that they're not parallel. So that would tell us, no, these are not, this is not a two congruent segments or two congruent shapes. So in this case, if they were, this would be a translation, and so it would have to be parallel lines, and it's not. And then matching each of the transformations, a reflection relies on perpendicular lines and using circles. Our translation uses parallel lines and the compass tool to make sure we get the correct distance of our vector. And then a rotation, we have to define the transformation and use the angle, know the angle. Okay, if you have any questions, any concerns, we'll go over those in class on Monday. Hopefully you guys do look at this before then. Have a great weekend, and let's just do our best. See you Monday.